10th standard CBSE Maths Chapter 3 Pair of linear equations in two variables. We know what are linear equations. It is in the form of ax plus by plus c is equal to 0. So here they have given pair of linear equations. So you'll have two linear equations and it is in two variables form. So x and y are the two variables here. Now they were given a situation. Akila went to a fair in her village. She wanted to enjoy rides on the giant wheel and play hoopla. So that's given in this figure. Giant wheel and this is hoopla game. And they have not given like how many rides she went or how many hoopla games she played. They've just given it indirectly. Like number of times she played hoopla is half the number of rides she had on the giant wheel. And each ride on the giant wheel costs rupees 3 and hoopla game costs rupees 4. How will you find out the number of rides she had and number of times she played hoopla? And the total amount she spent is given as 20. So only these conditions are given here. We'll see how to calculate the number of rides on giant wheel and number of games of hoopla. Now the same situation is worked out here. Number of rides that Akila had is X. Number of rides on giant wheel is taken as X. Number of times she played hoopla is given by Y. Now we know number of times she played hoopla is half the number of rides she went on giant wheel. So Y is equal to half X. That will be the first equation according to the condition given in the previous page. And the second equation would be 3 rupees for giant wheel and 4 rupees for hoopla. So you know number of rides on giant wheel is X and for each ride it is 3 rupees. So 3 into X will be the total cost for giant wheel. And number of times she played hoopla is Y. Cost of hoopla game is 4. So it will be totally 4Y. And she spent rupees 20 for both the rides. So we can say 3x plus 4y is equal to 20. This is for the amount she spent. This is the equation for the amount she spent. And this is the relation between the number of games she played on giant wheel and hoopla. Now we got two different equations and both are linear equations. This can be told as the pair of linear equations. And how to solve these equations, that will be seen in this chapter. Now you have graphical method of solution of a pair of linear equations. A pair of linear equations which has no solution. When you have two equations like this and if you don't have any solution, if you don't get the values of x and y here, that equations are called inconsistent pair of linear equations. A pair of linear equations in two variables which has a solution, that's called as the consistent pair of linear equations. And a pair of linear equations which are equivalent and they have infinitely many common solutions. If that's the case, they are called as the dependent pair of linear equations. And a dependent pair of linear equations is always consistent because they have many solutions, that is consistent. If you have one solution, that is also consistent. If you have no solution, that is inconsistent. Now they've given few points on this. The lines may intersect in a single point. If you take two linear equations and if you draw the lines in a graph sheet for them, the lines may intersect in a single point. In that case, you can say it as a unique solution or consistent pair of equations. If the lines are parallel, if you draw two lines and if they are parallel to each other, it means the equations have no solutions at all. They are inconsistent pair of equations. Then the third condition is lines may be coincident. Coincident means a line coinciding with another line. In that case, you can say they have infinitely many solutions because they coincide at so many points. So they have infinitely many solutions and they are dependent pair of equations and they're also consistent pair of equations. Now they have given three pairs of equations. If you consider these two equations, the lines intersect. If you draw the graph for this equation and this equation, you can see that the lines intersect. It means it has only a solution, a unique solution, because they intersect at only one point. So it means it has a unique solution. And the second case, you have two equations given in second Roman letter. That's the line coincides. Lines coincide. It means you have infinitely many solutions because they coincide at so many points. That's for the third condition. And here, third subdivision, the lines are parallel. If you draw the lines on a graph sheet for these two equations, those lines will be parallel to each other. It means they have no solutions at all. Now see in the next page, you have two general equations. A1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. When you draw a graph for these two lines, and if those lines are intersecting, you can say a1 by a2 is not equal to b1 by b2. If they are coincident, if those lines lie on each other, you can say this condition is satisfied. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. If they are parallel, you can say A1 by A2 is equal to B1 by B2, not equal to C1 by C2. Now, they have given a table with different examples for all these three cases. You have these two equations in first example, x minus 2y is equal to 0 and 3x plus 4y minus 20 is equal to 0. Always look for the coefficients of x. They'll be a1 and a2. So here a1 is 1 and a2 is 3 because you have to see the coefficient of x. For b1 and b2, look for the coefficient of y. So here you have b1 as minus 2 and b2 as 4. And the constant terms will be c1 and c2. In first equation, you don't have any constant terms. So that's c1. c1 is equal to 0. And in second equation, you have c2 as minus 20. Once you know all these values, a1, a2, b1, b2, c1, c2 values, you can calculate the ratios a1 by a2, b1 by b2, and c1 by c2. After you calculate these ratios, you have to compare them like a1 by a2 and b1 by b2. They are not equal in this case. So they are intersecting lines because you have this condition for intersecting lines. And if they are intersecting, they'll intersect at exactly one point. So they'll have exactly one solution or a unique solution. Now consider second example. You have two different equations. Consider coefficients of x as a1 and a2, coefficients of y as b1 and b2, and the constant terms as c1 and c2. Write the ratios in the next three columns. Look for the ratios. When you simplify them, each will be 1 by 2. So they'll be equal. All three will be equal here. So they are coincident lines. And since they are coincident lines, they lie on each other. So they'll have infinitely many solutions. That's for this condition. If they are coincident, all these three ratios are equal. That's what is given here. Then third example, x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. In this case also, you're going to calculate all these ratios separately, a1 by a2, b1 by b2, and c1 by c2. Then compare the ratios. You have only the first two ratios as equal and the last one is not equal. When you simplify that, you will get 1 by 3, which is not equal to the first two ratios. In that case, you can say these two lines are parallel to each other, and since they are parallel, you'll have no solution because they never intersect at all. You'll not have any solution for that. That's given in this third condition. Now example 1, check graphically whether the pair of equations x plus 3y is equal to 6, 2x minus 3y is equal to 12 is consistent. If so, solve them graphically. You have to check graphically whether these equations are consistent or not. If they are consistent, you have to solve them graphically. So first you have to draw the graphs for them. How to draw graphs for equations? You have to form a table before that. So if you take first equation, x plus 3y is equal to 6, x plus 3y is equal to 6. From that you find 3y is equal to 6 minus 6, and from that y is equal to 6 minus x, the whole divided by 3. That's what is given here in this table. So the first row will be x and second row will be y. Y is equal to 6 minus x by 3, and that's obtained from the equation given in the question. And you write different values for x. You can take any value for x, substitute in this equation. Y is equal to 6 minus x divided by 3, and calculate the values for y. Fill the table. Same way you have the second equation as 2x minus 3y is equal to 12. So that would be 3y is equal to 2x minus 12, because you are taking 3y to the right hand side, it becomes plus 3y, and 12 to the left hand side, it becomes minus 12. Now from this, y is equal to 2x minus 12, the whole divided by 3, and that's what is given in this table here. Now fill the table. Like, you can take different values for x and substitute those values in this equation and find the values for y. For example, if you consider x is equal to 3, I'm taking any value for x here. So if I take x is equal to 3, what happens here is, instead of y is equal to 2x minus 12 by 3, I'll substitute 3 in the place of x. So 2 into 3 minus 12, the whole divided by 3, which becomes 6 minus 12 the whole divided by 3, which becomes minus 6 divided by 3, which is equal to minus 2. So that's how you find the value of y. That's how you got this minus 2 here. So likewise, you can take any value for x and find the value of y. Fill this table. Here, minimum they have taken 2 values. You can take up to 4 values too. So you can extend this table too. Like you can take 4 values for x and find the values of for y. Now you have to plot the graph for this. Now, once you fill this table, you have to form the points like this 0, 2, 6, 0, and another one will be 0, minus 4 and 3, minus 2. You got 4 different points here. And first table is for first equation. So draw this line separately. 0, 2, plot it over here. 6, 0, plot it over here. Join those 2 points. You'll get a line like this. Then take these points 0, minus 4 and 3, minus 2. So 0, minus 4 will lie over here and 3, minus 2 will lie over here. Join those 2 points. Now see whether they intersect. They intersect at this particular point, which is 6, 0. They intersect exactly at one point. It means you'll have a unique solution here, and the solution is going to be 6, 0. It means x is equal to 6 and y is equal to 0. So that's how you write the solution for these linear equations, or for this pair of linear equations. X is equal to 6 and y is equal to 0. That's the solution. And since you got a unique solution here, the given pair of equations is consistent. Example 2, graphically find whether the following pair of equations has no solution, unique solution, or infinitely many solutions. See, if you draw the graph and if you find the lines intersecting at exactly one point, you can say it has a unique solution. If they lie on each other, if they coincide, you can say they have infinitely many solutions. Or if you draw the graph and if you get the lines as parallel, you can say they have no solution. So that's how you do this problem. Now you have two different equations given here in the question. One is 5x minus 8y plus 1 is equal to 0, and the second one is 3x minus 24 by 5y plus 3 by 5 is equal to 0. Now, to simplify this, to simplify the second equation, you have to multiply by 5 by 3. Why do you take 5 by 3 here? Because you have 3 by 5 in the constant term. When you multiply 5 by 3, what happens? You get 1 as the constant term. Same way, if you multiply 5 by 3 in all the terms, what happens? 3x minus 24 by 5y plus 3 by 5 is equal to 0. So here multiply by 5 by 3. 3 and 3 gets cancelled. You'll have 5x here. Here also into 5 by 3. 5 gets cancelled. 3 and 24 will get cancelled. You'll get 8 here. So minus 8y. And here it becomes 1 as I said before. So this becomes 5x minus 8y plus 1 is equal to 0, which is equal to the first equation. See, these two equations are same now. So what happens when you draw the graph for these two equations? You'll get exactly on the same line. You'll get the second line exactly on the same line because that's the same equation, right? So what happens here? You'll get the coincident lines. Equations 1 and 2 are coincident here. So it means they'll have infinitely many solutions. You can also draw graph and check for this example. Since I have mentioned as graphically, you have to draw the graph for these equations. You can form the table as I said before, and from those points you can plot the graph. Check the lines whether they are coincident or not. If they are coincident, say they have infinitely many solutions. Now example 3, Champa went to a sale to purchase some pants and skirts. When her friends asked how many of each she had bought, she answered the number of skirts is 2 less than twice the number of pants purchased. Also the number of skirts is 4 less than 4 times the number of pants purchased. So help her friends to find how many pants and skirts Champa bought. So see here, she has given indirectly, she has given the information indirectly here without saying the number of pants and number of skirts. So how to find them? Now let's take the number of pants as x. So number of pants is equal to x and number of skirts is equal to y. Now according to the question, you have the number of skirts is 2 less than twice the number of pants purchased. So twice the number of pants, 2x, 2 less than twice the number of pants, so minus 2, that is equal to the number of skirts, so y. So see here, number of skirts is, so y is equal to 2 less than, so minus 2, twice the number of pants purchased. 2 less than twice the number of pants. So it's going to be 2x because twice the number of pants. So 2x, 2 less than that. So minus 2. So this is how you form the first equation. For second equation, the condition given here is number of skirts is 4 times less, sorry, 4 less than 4 times the number of pants purchased. So 4 times the number of pants. So it's going to be 4x. 4 less than that. 4 less than 4 times the number of pants. So it's going to be minus 4. And that gives you the number of skirts here. Now see it again. Number of skirts is 4 less than 4 times the number of pants purchased. 4 times the number of pants is 4x. 4 less than, so 4x minus 4. That gives you the number of skirts. So this is how you form two equations using the conditions given in the question. Once you're done with the equations, you can go for the table. So draw the table for first equation, then draw the table for second equation. See here you have the equation in the form of y is equal to already, so you need not make any changes here. If it is going to be x plus 2y is equal to 3 or x plus 5y is equal to 4, something like that, you'll be finding y from that, and you'll be finding you'll be writing those values in the table here. But here the equations are in the form of y is equal to, you need not make any changes here. Just draw the table with first row as x value and second row as y value with this equation. Y is equal to 2x minus 2, and substitute different values for x and find the values for y. Once you find these values, once you fill this table, you have to make them as coordinates like 2 comma 2, then 0 comma minus 2 for first table, and for second table you have 0 comma minus 4 and 1 comma 0. Once you get these points, you're going to plot it on a graph. So 2 comma 2 lies over here. X is equal to 2 and y is equal to 2. So they both intersect over here. Plot it. Then 0 comma minus 2. 0 comma minus 2 is obtained on y-axis. So x value is 0, y value is minus 2. So you get it on y-axis on y dash side. Then 0 comma minus 4, that's also in y dash side. So 0 comma minus 4 will lie on the y-axis, minus 4 at minus 4. And 1 comma 0 is going to be on the x-axis because here y value is 0, x value is 1 here. So that point lies on x-axis. Once you plot these points, you have to join them. Join 2 comma 2 and 0 comma minus 2 because they are for this particular equation. So join them separately. 2 comma 2 and 0 comma minus 2 should be joined separately. So that gives you this line. Now go for the second set of points. 0 comma minus 4 and 1 comma 0. Join them separately. That gives you this line. Now check whether they intersect. Yes, they intersect at one point. Where do they intersect? They intersect at this point. This point is 1 comma 0. So here the solution is 1 comma 0. It means x is equal to 1 and y is equal to 0. That's the required solution for this pair of linear equations. It means x is taken as number of pants. So number of pants is 1 and number of skirt 0. So it means she purchased one pant and she did not buy any skirt. This is how you find the solution when conditions are given. You have to form the equations using the conditions. Then you have to draw the table for those equations. Then plot the graph for those table values and check whether they are intersecting or they are parallel or they are coincident. Based on that, you can say the number of solutions.